Hello everyone, greetings and welcome. I am Abhishek Sarkar and along with my group partner Debojit Barman, I am going to give a brief overview about my final year project that is done under the guidance of Professor Kandarpa Kumar Sarma sir. The topic of our project is flood detection and avoidance system. So let's begin. So this is the outline of the project and I'll start with a brief introduction about the project. So, as we all know how every year flood takes place around the world, which results a huge loss of infrastructure, properties and even livelihood, where our own Assam is an example for the same. So, Debojit and me decided to come up with an idea to develop a system that would detect and predict the forthcoming of flood. So hence, this also becomes the motivation and reason behind the project. Now, speaking of our goal is to basically develop a system that can predict the upcoming flood and would alert the local authorities to take necessary and precautionary measures for the same to minimize the damages and loss. Here are some of the literature reviews that we have gone through. Now, let's focus on the hardwares that we have used. A DHT11 sensor is used to measure the temperature and humidity. Two ultrasonic sensors have been used for the measurement of water level and rainfall. Next, a water flow sensor is also being used to measure the flow of water. Next is an Arduino Uno board that receives all the sensor data. Then a Node MCU or ESP8266 sensor that receives data from Arduino through serial communication port. Then is a servo motor for the operation of dam gate, and lastly a buzzer which will trigger an alarm. This is the block diagram of our project, and here as we can see that all the sensors that are recording data are connected to the Arduino board where all the data gets collected. Now the Arduino board is connected to the Node MCU through serial communication port. The Node MCU there helps in communication with the internet where all the recorded data are transferred in the ThinkSpeak platform for analyzing and visualizing the data. And from ThinkSpeak the data is sent accordingly to the Google Colab where deep learning algorithm for forecasting is applied. Then after that a web page gets launched where the prediction takes place, and then the whole process comes to an end. This is the flowchart of our project. Let's try to understand this. Firstly, all the connected sensors starts to sense and collects their respective data, and the recorded data are collected to the Arduino. Then the data are sent by the Node MCU to the ThinkSpeak platform for analyzing and visualizing. Then after that, if the water level does not cross the threshold limit, then the system will not proceed further. And if it does, then a buzzer will get triggered and the data from the ThinkSpeak will get transferred to Google Colab where deep learning algorithm for forecasting is applied. And after that a web page will get launched where prediction for flood takes place. Then the whole process comes to an end. Here is a picture of our prototype that we have built where all the sensors are connected. Now let's see some of the resources that we have used. Firstly, software serial. The work of software serial is to establish a connection between Arduino Uno and Node MCU. And if you ask why we are using this, the simple answer would be, as in our model, the recorded data should get transferred to the ThinkSpeak, and as Arduino does not have Wi-Fi, where Node MCU does have Wi-Fi, so we are using this. Next is Arduino JSON, and what it does is it breaks more than one digit number into individual number. Suppose there are 5 variables A, B, C, D and E, and A has a value of 1234, but B, C, D, E has 0 as value. Then what Arduino JSON would do, it would break 1234 as individual number and assigns them to B, C, D, E. Means B will now have a value of 1, C will now have a value of 2, D will now have a value of 3 and E will now have value of 4. This is the visual representation of ThinkSpeak platform showing different sensor data in a graphical form. Deep learning. It is one of the most crucial part of our project. Deep learning is a machine learning technique that can learn features and tasks directly from data, where data can be images, text, or even sound, and in our case, the model learned from text datasheet. Now let's see the libraries that we have used. First is Keras. Keras is a deep learning API for neural network. It supports multiple neural network computation and makes implementation of neural network easy. Next is Pandas. Pandas stands for Python for data analysis. It is the most popular tool for data cleaning and analysis. Pandas work with data frames and series and is best suited for working with heterogeneous data. Then is the NumPy. NumPy means numerical plus Python. With the help of NumPy, for example, if you want to do any array-based or metric-based calculation, you can use NumPy. Very complex calculation can be done very easily with NumPy, and NumPy works with same kind of data. The network that we have used is feed-forward neural network, and here is a pictorial representation for the same. As we can see in the picture that it is a unidirected graph, which means there is no feedback connection or loop in the network. It has input layer, output layer, and a hidden layer. In general, there can be multiple hidden layers. Each node in the layer is a neuron, which can be thought of as the basic processing unit of a network. Additionally, we have used two more frameworks, namely Streamlit and ngrok. Streamlit helps to create beautiful custom web apps for machine learning and data science, and ngrok is a cross-platform application that helps developer to expose a local developed server with the internet with minimal effort. Here is a screenshot of our result that we have obtained, and as we can see, one particular random set has been highlighted here, and the highlighted set is selected and filled in the website, and upon prediction it shows that the water level is 3.17 centimeter, which means water level is below the warning level. Video demonstration. Here is a video demonstration that shows the working of our model.
This is a video demonstration of our final year project, flood detection and avoidance system. This is the prototype that we built. Now we'll proceed with the testing of the sensor. This is the ThinkSpeak page where we will visualize and analyze our data. Currently the values showing our water flow of 0 liter per minute, rainfall is 1 centimeter, humidity is 81%, and water level is 3 centimeter. As you can see on both sides, same amount of raindrops or water drops are falling. So we can say that the amount of water drops that is falling on the left hand side in the bucket is the same amount of waterfall that is falling in the rain gauge meter. Through this we can get to know we can measure the amount of rainfall that is happening over the riverbed. Currently the rain gauge is showing the value more than 1 centimeter. Now let's check it on the ThinkSpeak. And now in the ThinkSpeak screen, rainfall is showing 1 centimeter. Next, we'll check the water flow. As you can see, the water flow sensor has changed to 532 liter per minute on the ThinkSpeak screen. Currently on the screen, the water level is 3. The water level has become 4. And also the buzzer is going on and the dam gate is open to release the excess water. It will send a signal in the nearby areas when the water level reaches the threshold. As you can see, the water level is still 4 centimeter, and the buzzer and the dam gate is still open. Now it is closed, and now the water level has become 3. So as the water level goes below, the dam gate and also the buzzer goes off. After visualizing the data on ThinkSpeak, we'll export our data in CSV format. I've already downloaded the dataset. Now I'll move to Google Colab, where we have our deep learning code. We have uploaded our dataset and we have run it. and we got an accuracy of 84%. Now we'll save the model. Now launching the web page. So here we can do our prediction, taking some values. So the water level is 5.31 centimeter, and water level is above the warning level. That's all. Thank you.
Here's a Gantt chart of our project, and as it's the month of August and we are at the end of our project. Now let's see some of the future scope of the project. For the time being, we are using our laptops as the power source, and in future, the whole system can be made to work with battery as the power source. And for better mobility, the size of the components of the system can be minimized. Now, I would like to conclude some points about the project. The whole system is a cloud-based system, and we have taken advantage of platforms like Google Colab and ThinkSpeak for the project, and we have avoided using physical storage devices. This project is just an idea, and with proper modification, support, and guidance, it can be deployed for real-time usage. And lastly, we cannot outrun from the wrath of nature, but we can surely outsmart it to some extent. That's all from our side. Thank you.